All right, so this is chapter 2.6, video number 3. Again, trying to find the asymptote, zeros, holes, all the different critical points, and then graphing these equations. So we have 2x plus 3 over x minus 1. Vertical asymptote, we just call that VA for brevity. Our vertical asymptote. Again, we look at the denominator, so x minus 1 equals 0, x equals 1. Go ahead and draw that in. X equals 1. Horizontal asymptote. We look at the degree of both our numerator and denominator. They have the same degree. They're both x. Therefore, n equals m. So y equals a over b, which is 2 over 1, equals 2. So our horizontal asymptote, y equals 2. Next question, does it have any holes? Nope. And let's see, y-intercept. We would put 0 in there. Our y-intercept would be -3. 0 and 1, 2, 3. And let's see, could we find our x-intercept? To find our x-intercept, we come up here and we look at the numerator. We go 2x plus 3 equals 0. 2x equals -3. X equals -3 halves. So 1.5, -1.5. There's our x-intercept. So we really kind of already have our 2 points that we need for this part of the graph, since we know that the general shape of it is the same. Now we can kind of just focus on the right part of our graph, so x and y. So for my negatives, I mean, I could plug in, well, we know, we already know at -3 halves, we have 0. If we wanted to, we could do another, we could go -1. That would be -1/2. All right, so -1, it's -1/2, that point there. But we already had our points with our x and y intercepts. All right, so let's plug in some values over here. I'm going to go with 2 and 3, and with 2 it's 7, and with 3 it's 9 halves. So 1, 2, it's 1, 2, 3, 4, 5, 6, 7. And for 3 it is 9 halves, which is 4.5. That's 1, 2, 3, 4.5. And so we have something like this. Okay. Number 2, again, one of the main things we want to do is, when possible, we want to factor x, okay, -2, let's see, they're different. The negative means they're different. The positive means that the larger value is going to be positive, so it's x plus 2, x minus 1. And then down below here, x, let's see, 6, that's going to be 2 times 3. This means they're different. This means the larger is negative, so -3, +2. And we notice these cancel out, so I'm just going to put it in here right off the bat. We have a hole, and that hole is at -2 is the x value. We plug -2 into our remaining equation, so -2 minus 1, -2 minus 3. -3, -5, so 3/5. All right. Let me just erase that for now. Go back up here to our vertical asymptote. So the question is, what do we have left over? X minus 3 equals 0, so x equals 3. So we'll come down here, 1, 2, 3. And that's one of the key things. We want to factor that out, because in this case, if we factor it out, we cancel out that x plus 2, that becomes a whole. So x equals negative 2 is a whole. It's no longer one of our asymptotes, right? So this is our only asymptote at x minus 3, so x equals 3. Horizontal asymptote, they have the same degree, n equals m. Therefore, y equals 1 over 1, which would be 1. Go ahead and put that in. Okay, and then let's see, I'll just go x, y. 1, 2, 4, and 5. Give me 0, negative 1, 3, and 2. So let's see, 1, is it 0? And again, I'm sorry, I skipped some things here. X minus 1, that gives us this this x-intercept, right? X minus 1 equals 0, so x equals 1. So that told us where our x-intercept was. I kind of skipped through that. We found the point when we did this here. All right, 2 is negative 1. At 4, 1, 2, 3, 4, we're at 3. 1, 2, 3. And at 5, we're at 2. All right, so we have, this comes along here through that point. And then over here, we're coming through. Now we have this negative 2, and what did we figure it out was? I think it was 3/5 or something like that. 1, 2, 3/5. So we have a hole here. So we need to make sure we include that into our graph. All right. Trying to zip through here. Last one. All right. Again, factor just in case. X minus 1, x minus 3, x plus 3. My vertical asymptotes are going to be x minus 3 equals 0, so x equals 3, x plus 3 equals 0, x equals negative 3. Okay, vertical asymptotes. Horizontal asymptote, n is less than m, so y equals 0. I should be doing this in a different color, but there's our asymptotes. Let's see. We want, let's see, our x-intercept. X minus 1 equals 0. X equals 1. So we have an x-intercept here. Interesting. Okay. And then y-intercept. Put zeros in there. Y-intercept would be at 1/9, right? 0 and 1/9. Our x-intercept was at 1 and 0. So 0 and 1/9, we have that. That kind of tells us a little something about how this is going to look. And let's put in some points. X and y. And we've got -5, -4, -1, 0, 1, 4, and 5. And I just kind of picked those out before. And you have to trust me on these numbers. I think they're right. If they aren't, they're close. 1/9. 1 is at 0. This is 3/7, and this is 1/4. All right, so a little bit of math we had to do there. Plug in these different 1, 2, 3, 4, 5. We have 3/8 down here. This is down here. Okay. And at negative 1, we had 1/4. That ninth was, so this looks like this. Since this point is positive, and at 1 we're at 0, here we're kind of in between. Kind of get the gist of how that's going to look. And at 5 it was 1/4. And at 4 was 3/7. So kind of like that. All right, very quickly here, we're going to not worry about number 4 so much. We're going to look at number 3. What all do we have here? Well, we have zeros at 2 and negative 2. And the zeros we find from our numerator. So we can say x plus 2, x minus 2. All right, and then remember our vertical asymptotes, that gives us comes from our denominator. So those look to be at 1 and negative 1. So that's going to be x plus 1, x minus 1. And we look and we have a y equals 1 as our horizontal asymptote. So in that case, we know that n has to be greater than m. Oh, no, I'm sorry. They have to equal each other. N equals m, then it's y equals a over b. And since it's 1, then we know that it's not y equals 0. So the degrees of these are going to be the same. So if it says not to multiply or that put in factor form, you would leave it as it is, or you would multiply it out, and this gives you x squared minus 4 over x squared minus 1. All right, again, the vertical asymptotes give you your numerator, your zeros or your x-intercepts give you your denominator, and then you just have to see what the relationship is, or where your horizontal asymptote is, and then how that relates to the degree of your numerator and denominator.